Alright friends, the first principle we want to discuss is inheritance. In object-oriented programming, it is possible for a class to inherit from another class. Suppose we have two classes, animal class and cat class. We can make the cat class to inherit from the animal class. We just need to put the class from which it inherits inside parentheses. In front of the cat class, we are going to put parentheses, then we are going to mention the name of the class from which it inherits, animal. The class that inherits from another class is called the child class, while the class from which it inherits is called the parent class. In this case, the cat class is a child, while the animal class is the parent class. The implication of this is that a child class would be able to access all attributes and methods in a parent class. Now, let's define some attributes and methods in the parent class. Def eat. It takes the first parameter as self because it is an instance method. Print animal is eating. Let's define another method. Def move. The first parameter as self. Print animal is moving. Now let's go and create an instance of the cat class. Cat1 equals cat. Cat1 dot. Whenever you call a method on the cat instance or try to access an attribute, it first checks the cat class to see if they are declared. If they are declared in the cat class, everything works fine. If they are not declared, it will go up to look for them in the parent class. Let's call the eat method on a cat instance. Cat1 dot eat. The VS Code is already suggesting some methods. Let's also declare another class attributes. Animal underscore type equals domestic. Now let's access it from the cat instance. Print cat1 dot animal type. Let's execute the program to see what happens. It turns out that a cat is able to access all attributes and methods from animal due to inheritance. What happens if within the cat class we define a method that has already been defined in the animal class? Let's try that out. Def eat self print cat is eating. As mentioned earlier, the first place checked when looking for attributes and methods is the class itself before going up to any parent class. The expected output from the eat method call is cat is eating. Let's run the program to see what happens. It works. Cat is eating. What you've done here is called method overriding. It involves redefining a method that is already defined in a parent class. The benefit of this is that it allows child classes to implement methods the way they want. But sometimes you may want to explicitly call a method in the parent class. The super function comes in handy here. Now let's make use of super. When you use the super function, you are essentially telling Python to provide you with access to the parent class. So once we add a dot after the super function, the code editor displays the attributes and methods that we can access on the parent class. We can then choose to call any of these functions. Now let's execute the program again to see what happens. Animal is eating is printed to the screen because we are calling a method from the parent class by making use of the super function. Remember that the super function allows you to access attributes and methods on the parent class. This type of inheritance is called single inheritance because we are inheriting from a single class. Alright friends, Python supports what is known as multiple inheritance. This means that a single class can inherit from multiple classes. When this happens, the child class will be able to access all attributes and methods from all these classes. Another question arises: when the same method is defined in multiple parent classes, which one would the child class pick? As you can see, the move method is defined in all these classes. Move in parent 2 and move in parent 3. If we call this method from a child class, which one gets executed? Now let's assume that there is no move class in the child class. We are going to comment out this method Now let's create an instance of child1. Child1 equals an instance of child1. Child1 dot move. We have this move method defined in all the classes parent2, parent1 and parent3. The answer to this question is provided by what we call method resolution order, MRO. Methods are searched from bottom to top and from left to right. Bottom to top means that a method is first searched in a child class before moving up to a parent class. Left to right indicates that it traverses from left to right when searching in parent classes. Now, if I were to run this program, the expected output would be parent2 move. The move method cannot be found in the child class. Then it moves up to search for it in the parent classes, and the first parent class is parent2. When it looks for the method in parent2, the method is found. That means parent2 move would be the expected output. Let's execute the program. Great, the answer is parent2 move. This rule also applies when the super function is used to access an attribute or a method in the parent class. It follows the method resolution order when searching. Let's make use of the super function in the move method, super.move. Alright, so let's change the order of the parent classes. Parent3 to be the first. Now, if I were to run this program, the expected output from this move method call would be parent3 move, because the move method is found in parent3. Let's execute the program again to see the outputs. Parent3 move. A class has the MRO attributes, which allows you to inspect the method resolution order. Print child1 dot double underscore MRO method resolution order. This is going to print out the method resolution order. Let's execute the program. As you can see, the first class is child1, followed by child3, 2, 1, and finally objects. Let's put parent1 to come first. Parent1. Let's execute the program again. Great, as you can see, immediately after the child we have parent1. Alright friends, now that we have some understanding of inheritance, let's put it into practice using the product class as the parent class. We are going to create a new class called shirts that inherits from product class. Shirts, it inherits from the product class products. Pass. It means that shirt will be able to access methods and class attributes from the product class. Let's create an instance of shirts. Shirts1 equals shirts. Print shirt1, which is an instance of the shirt class. If you notice, we are not yet passing information to the shirt. Let's execute the program to see what happens. As you can see, Python throws an error that the init method of product requires 2 arguments. Whenever you instantiate a class, Python will check if you've defined an init method inside the class. We didn't declare this init method in the shirt class, but because shirt is inheriting from products, Python goes up to look for that method in the parent class, which is this init method we have here. As soon as Python sees this init method, it calls it, but the needed arguments, which are name and price, could not be found. To resolve this error, what we can do is to create an init method in the shirt class that takes the needed argument as parameter. Let's define the init method in shirt. Def init self, it takes the first parameter as self. Then we want the name to be passed as well as the price. This means whenever we want to instantiate this shirt, we must provide the value of name and price. So now let's make use of the super function. This super function returns the parent class super.init. We want to call the init method on the super function. Remember that this init method is pointing to the init method in the parent class, which is the init method in product. The init method in product takes name and price. So we are going to pass the name and the price. You don't need to pass self. Self is the actual instance you are trying to create, and it is automatically passed. Now let's go ahead and run the program again. I forgot to pass the name attribute and the price to the shirts. 20. Now let's execute the program again to see what happens. Great, it works. Let's call the get total price method. Total price equals shirt1 dot get total price. We need to pass the quantity, let's say 5. Point total price total price. Alright, let's execute the program to see the output. Great, it works. Total price is 100. Let's also call the get product counts. It returns the length of all the products. We are going to say the shirt class dot get product counts. Let's point this to the terminal. Point. Alright, so let's execute the program to see the outputs. Great, it works. We only have one product. Let's add one additional product. Socks. Price is 10. Right, so let's execute the program. Great, it works. So all the methods and attributes present in the parent class can be accessed in the child class. The benefit of this shared class is that you can include methods and attributes that are only specific to the shared class, or you simply want to override the implementation of a method in the parent class. Encapsulation is when you prevent object attributes from being overridden from the outside. It is a way of protecting and restricting access to data. We mentioned while discussing getters that you can hide an attribute from the outside by using a double underscore before the attribute name. When you do this, it means that this attribute is only available for use inside this class. Other programming languages such as Java use the private keyword to signify that an attribute can only be used internally. We are able to access the double underscore price attribute only inside the class. So if we try to access it from outside the class, it won't work. Double underscore price. Print this to the terminal. Print. Let's execute the program to see what happens. It shows attribute error. Product object has no attribute double underscore price. Do you mean price? You can also do the same thing for methods. You can make a method to be private by making the name to start with double underscore. Let's call it process report. Def process report. Print processing. This kind of method is private. It can only be used inside the class. Let's create another method that sends the report to the user. Send. This method is not going to be private. Self dot double underscore process report. As you can see, we are able to access the process report method within the class. Print report sent. Report sent to the user. So this means from a product instance, product 1, we can't call this process report because it is a private method. It is meant to be used inside the class alone. If you know that a method is of no use when it is accessed from outside the class, then you can make it private. As you can see, this process report method is used internally by another method, which is send report. Let's execute the program to see what happens. Attribute error. Product object has no attribute. Process report. Now let's call send report to the user. Send report. Let's execute the program. Great, it works. Processing. Report sent to the user. So this is how you can make attributes and method to be private. That is encapsulation. You are protecting them from the outside world. The abstraction principle says that you should only show necessary information and hide unnecessary information. Consider the example of visiting youtube.com to search for a specific video. Upon typing and pressing search, various videos are displayed, and that's the extent of your knowledge. The details of where the videos are stored, how they are displayed on the screen, and all the operations happening behind the scenes are not known. These hidden details are abstracted from the user because the user does not really need them. Understanding the internal workings of the entire YouTube platform is unnecessary for the user. The whole process of hiding unnecessary information from the user is known as abstraction. Abstraction is concerned with the high level and not the details. Applying this concept to programming, abstraction can be achieved through abstract classes. It means that we can have an abstract class which only provides a high-level overview of what something does, without revealing the details. So we can define an abstract class called abstract product. Class abstract product. This class needs to inherit from ABC for it to be an abstract class. We need to import ABC from ABC, imports ABC, and abstract method. We can define some abstract methods within this class by decorating them using the abstract method. Get total price, self, pass. We need to decorate it with abstract method at abstract method to make it an abstract method. Abstract classes do not reveal implementation details. An abstract class is only showing a high level of the methods in a product. Every class inheriting from these abstract products must implement this method. Now let's create a product class that inherits from the abstract class. Class product. It inherits from abstract product class. Def get total price, point price is 50 naira. Let's go ahead to instantiate the product class. Product 1 equals product. So now we can easily call the method on the instance product 1 dot. Let's execute the program to see the output. It works. Total price is 50 naira. Abstract classes are meant to be subclassed. Let's create another product. Product 2 abstract product, an instance of abstract products. Let's execute this program to see what happens. Python raised a type error. Can't instantiate abstract class abstract product. So we are not meant to instantiate an abstract class. Any class inheriting from an abstract class must implement the abstract methods declared in the abstract class. Let's decide to omit the get total price. So now let's try to instantiate product 1. Let's execute the program. Python raised an error. Any class inheriting from the abstract class must implement the abstract method. Remember that the abstract method is just a high level. It doesn't provide the implementation. I hope you now understand the meaning of abstraction. Polymorphism is the ability of an entity to have multiple forms, depending on the context which it is used. First, let's take a look at the len function in Python. The len function behaves differently depending on the context which it is used. With a string data type, it returns the number of characters in the string. For a list data type, it returns the number of items in the list. Let's execute this program to see the output: 3 characters and 5 items in the list. A function is said to be polymorphic when it behaves differently in different scenarios. This len function is polymorphic because it behaves differently in different contexts. Similar to function polymorphism, operator polymorphism is when an operator behaves differently depending on the context it is used. When you use the plus sign on strings, it performs string concatenation, Meanwhile, when it is used on numbers, it performs summation. This behavior is known as operator polymorphism. If you want your custom object to respond to plus, minus, and so on, then you need this set of special methods to be defined in your class. Domo_sub and so on. Some programming languages allow you to have 2 or more methods with the same name but different arguments. In those programming languages, the implementation would look similar to what we have here. You would have multiple methods with the same name. Python does not support this exact behavior. So whenever you call the method, it picks the one where the arguments match. For example, if you call the sum method with 2 arguments as integers, then the first method would be executed. If 3 arguments are passed as integers, then the second method would be executed. Python does not support having multiple methods with the same name but different arguments. However, you can achieve a similar behavior using default values. Let's create a method with a default value A, B, C, and a default value of C, none. If you call this method with just A and B, it works because you have provided a default value for C. When C is provided, then this default value is not used. Another kind of polymorphism is method overriding. A child class inheriting from a parent class is able to override or redefine an already defined method in the parent class. This process allows a single method to have different behavior. We've discussed method overriding in detail. Make sure to check it out. If you enjoyed this video, make sure to give it a thumbs up. For more practice questions, be sure to check the description below. Subscribe, like, and comment. Thanks.